Hello, yeah. Um, I'm Ananya K. I'm a project intern at CDAC, and our paper is on identity management solutions for IoT. And I have my friend Rashmi Harish on the Zoom call with me. We've done this project under the guidance of Dr. Mohammed Misbahuddin, Associate Director and Group Head of ACTS BD. Yeah. So firstly, let's dive into why we've chosen identity management solutions, specifically for IoT devices. Firstly, this is the snapshot of the various IoT concerns and threats that once you Google, this is the list of snaps that you get in terms of the number of malware attacks increasing on IoT devices, the amount of risks that IoT poses, and there's an INTERSOG that has surveyed IoT security threats for IoT devices, and it has estimated the amount of impact it has on critical operations in the IoT, etc. Right? IoT has also been the the top two most common targets for hackers in 2019, and um, yeah, and this has totaled 1.5 billion violations in the year 2019, which means, and it's been more than doubling year on year. Given that, IoT has been most highly vulnerable for security attacks, the solution that solves most of these problems in the various layers of IoT is solved by the concept of identity, right? Identity, I'll come to what identity is. This is the agenda of how I'll go through this presentation. Firstly, I'll go through what an identity is, types of identities, traditionally used identities for IoT devices. My friend Rashmi will talk about research in IoT IAM, and we'll move on to commercial solutions, and then I'll conclude it. Right? Firstly, on what is identity. And identity is basically an attribute of an endpoint that is, um, that is used to identify it locally, remotely, and logically. So there are two types of identities, VCs and DIDs. VCs are verifiable credentials, more like an ID card, except that it's digitally signed and it's completely digital. And there's an issuer that issues the identity holder and the verifier that verifies the given verifiable credential. The only difference between a distributed identifier and a verifiable credential is the verifiable data registry. The verifiable data registry in the DID, or the distributed identifier, is comprising of distributed ledger technology like blockchain that that stores these identities in the form of a ledger. And DIDs also give a lot of benefits to the users in terms of giving them complete sovereignty as to decide what their identities are going to be, in terms of me being a presenter here in this hall, or me being a student in my college, etc. Right? So I can have different identities for the same endpoint is what the whole concept of DID is. These are the examples that I've tabulated, I've listed, and traditional examples of VCs include NFC, or near field communication, that uses radio frequency or RFID tags to identify devices. MAC, or the medium access control address, that's assigned at the data link layer, is again a traditional verifiable credential. SIM, you might think it's specific only to a phone, but no, we have IoT SIMs, we have M2M SIMs, eSIMs, and multiple other subscriber identity modules, which are present for all IoT devices. Moving on to DIDs, there are more DIDs coming up, but these have been highly used, right? IOTA is basically like blockchain, except blockchain uses chain data structure, and IOTA uses tangle data structure, tangle data structure. SSI, or self-sovereign identity, is again a distributed ledger technology that uses the blockchain where the identity is generated. Moving on, identity management. Identity management is the creation, administration, and deployment of identifiers, credentials, and attributes. Although these might sound very, very similar, identifiers, identifiers. For example, I have an ID card, which forms my identity. Identifier is my name, and credential is the card number or my university number that provides evidence around my claims about identity. And attributes include data describing the characteristics of me. For example, my photo ID could be my attribute because it describes my physical characteristics. So all these three together comprise the identity. And one more important terminology that we should know is the device identity lifecycle, which is the entire process of designing a device by security standards, provisioning, assigning CA or RA, and managing and revoking as well as destroying the device identities. Yeah. Rashmi will take over from here. So.
Research papers in the field of identity of things. Among that, we have chosen 4 papers to present today. Please go to the next slide. We have chosen this paper because it represents the information stack that has been proposed. Um, we, we see similar lines between identity of user and identity of things. Inheritance, possession, and knowledge are the layers of information stack for identity of user. Inheritance is something that we are, example, fingerprint. Possession is something that we have, like a smart card. And knowledge is something that we know, such as a password. In analogous to this, in identity of things, inheritance can be a PUF, that is this digit, that is the fingerprint of a silicon chip, and association or possession can be the link to which we can link the device. Example, smartphone. So under the category of smartphone, our device will be categorized, and knowledge will be something that the device knows, which is its a number, IMEI number or SIM number. And context is the most important layer for identity of things. Uh, for example, a wireless sensor network deployed to detect forest fires has the same context. So it makes it easy for mass identification of a group of sensors. I can connect multiple devices that I own to each other, and they will have the same context that they belong to me, hence easily identifiable. Next slide. In PKI-based identification for devices, the standard X509 certificates are not preferred due to their large size, complexity, and requirement of higher processing powers on the end device. Instead, lighter weight CBOR, that is concise binary object representation certificates, which are X509 compliant, are used. These certificates are derived using ECC, that is elliptical curve cryptography, and presented more efficiently than the ANSI notation. The profile is represented in the figure. The best use case described for this PKI fusion with blockchain technology are applications like smart city, where the reliability of the data is most important. Decentralization avoids single points of failure, and the blockchain technology allows for easy extensibility without unnecessary human intervention. Next slide. The decentralization due to blockchain leads to elimination of single points of failure which were earlier present in PKI. This paper draws ideas from cryptocurrencies and shows implementation on an IoT network. Name value storage, or NVS, is an extension of Bitcoin that sits on the Bitcoin blockchain. It increases security of the network by discouraging unnecessary addition of blocks to the chain and unnecessary transactions. The B nodes in the figure on the screen are blockchain nodes which also act as NVS servers, which generate and validate transactions, thus creating an NVS database. The IoT devices are called NVS clients, which will send queries to the blockchain nodes. The paper further highlights how device setup, configuration, ownership transfer takes place. Next slide. Blockchain, along with PUF, proves uniqueness of the device. POF proves the uniqueness of the device, and blockchain authenticates it, thus making it a stronger technology than each of them individually. During manufacture, only a public key, mask, and helper data need to be stored for authentication and recovery. Private key is generated by the device itself by issuing a challenge and receiving a response, which will be the output of the PUF, which is the PUF response, thereby reducing security risks of
Hello.
producing the key
Uh,
outside of the system.
may request you to go faster.
Yes,
2 more minutes.
yes, sir. The second layer of security is due to the blockchain, and the distributed ledger technology makes authentication independent of the manufacturer. Next slide.
Here are the commercial solutions that are being proposed by the leading companies in the field, right? Firstly, we discussed Intertrust, which proposes a model for device identities based on PKI. It describes device identity as a data structure with different attributes. This is the data structure that's proposed by Intertrust, and metadata, authorization statement, cryptographic credentials, and signature block are the attributes of the entire device identity. Each of these attributes contain a lot more information elements which can be tailor-made or based on the customer demands. Moving on, Global Sign. Global Sign proposes a zero-touch chip-to-cloud provisioning service that using certificate-based identities for IoT devices. It actually has more solutions, but this particular paper is it's a collaboration between 4 of these companies: Global Sign, Infineon, Eurotech, and Azure. While Azure does cloud provisioning and using the IoT services, Eurotech provides the IoT integration platform for the same. And Global Sign and Infineon together uh, code sign the EK along with a digital certificate, which is later sent to the IoT integration platform. This ensures both the root of trust and robust PKI services for security purposes. Prime key is it emphasizes on seamlessly integrating both OT and IT, and the solution that it proposes is code signing, combining code signing along with PKI. So this is the flow diagram of the entire code signing process, and after the software module is code signed completely, it is sealed by the private key, and the respective public key is then the respective public key is generated using the PKI infrastructure, the public key infrastructure, and that's how PKI and code signing are combined. In intrinsic ID, what it does is what the solution proposed is that it uses SRAM puffs. We've seen what puffs are already throughout all these lectures, and SRAM puffs are static random access memory puffs, which do not need a challenge response pair per se, which means because of the process variation in the submicron particles during the manufacture itself, the SRAM startup values are enough to provide this silicon fingerprint for the entire device, which means you don't have to send challenge and expect a response pair for every transaction, but the startup, you can just power it off and on, and the startup value is enough. Concluding, these are the challenges that is posed by the identity management in IoT specifically, right? Firstly, is lack of standardization, which is something that's been consistently discussed through a lot of lectures today, right? For example, the interoperability standards and the protocol standards, even though there are a lot of protocols like REST and DDS, CoAP, etc., there is a lack of standards. The process of developing a standard protocol has been challenging. And existence of constrained devices, specifically in IoT, a lot of devices have a lesser computational capability and processing power, which means the certificates have to be lightweight in order to maintain higher amount of security. Lastly, ethical issues also involving privacy and consent to data access. We know that big data exploits the vulnerability in security to extract data, right? Limitations of WSNs including electromagnetic interference, attenuation, distortion, etc. Retrofitting is also something that's been discussed, especially if IoT devices, it's harder because it requires manual intervention for IoT devices to gather this identity and store it manually, right? Lastly, coming to this identity management solution itself cannot evolve on its own, right? There are a lot of other pillars that it's dependent on, including secure data management and processing, huge databases, big data notification management system, etc., which also need to evolve along with it, which is also challenging, and that's why, yeah, thank you.
Uh, the session with the theme PKI ecosystem concludes. May I invite Professor Shyam Sundar to honor the session chair, Mr. DK Burman. Thank you, sir. The next session is on diverse applications of PKI. I would like to invite the session chair, Mr. Samshuddin Khan from the office of CCA to chair the session. Over to you, sir.
Thank you. Good afternoon to everyone. For next session 3, I call Mr. Vivin Krishnan, Srija, Sumitra, Binu, and Muhammad Misbahuddin on the topic a JSON web signature based adaptive authentication modality for healthcare application. Over.